Alrighty, let's get started. So, we are now in week 13. No, week 12. Oops, wrong one. I looked at the wrong one. Okay. So, what is week 12? Week 12 is a very important new concept that I'm going to teach you, and that is the concept of object-oriented programming. So, all the programs that you have had to work with so far are basically what we know as procedural programming, or you have a bunch of procedures or a bunch of functions, and they're all just out there by themselves, and then maybe you have some variables and stuff like that, and you could, I guess, put a bunch of variables inside of a function, and that's a way to group some of your code. But more is needed, okay? So if you wanted to have a way for you to bundle up a bunch of properties and a bunch of actions into something, that is where objects come in handy, right? And first of all, what are objects? And in computer science, everything is an object, right? So the table is an object, the chair is an object, the dog's an object, you're an object, right? And there's some jokes in there about why did the programmer lose his girlfriend? Because he treated her like an object. Okay, so all right. So let me tell you about objects. So let me just look at this real quick. Okay, so I have a whole bunch of I've written a whole bunch of things in there. All right, with some examples and stuff like that. But it's best if I just dive right into this thing and show you what it is. All right. So here's for example a class called Circle. All right. So the way we are going to create models for objects or templates for objects is using classes. Right. So the class is a template for an object. And again, what is an object? Some real world thing like a circle, for example, right? And the circle has pretty much one property, which is its radius, right? Depending on the radius, you can change the size of the circle, and that's about all you can do with it. Okay, so there's a property for my circle which is called a radius, right? And then the radius property is this r here. Okay. Now, objects in Python are actually not as user-friendly as you would think they should be, maybe. If you were to actually play around with objects in C++ or in Java, you would find that those languages are actually a little bit more user-friendly as far as making a new object and changing the properties of an object and stuff like that. And I mean, just the syntax is a little bit simpler. So I don't know why Python deviated from the normal course where everything's really easy to work with, and all of a sudden when we do objects it's like a little bit more complicated than it needs to be, but it is what it is. Anyway, so there's a couple of different things in an object. So of course we're going to have a property of an object, and that is this r variable in here, right? And in Python you have to say self all the time. That's one of the things I don't really like about it. But so in other languages, you pretty much you don't have to worry about self and stuff like that. But in Python, in order for you to indicate that this variable r belongs to the object circle, you have to say self, right? So self.r is the variable r which belongs to the circle object. Okay, this thing here that you're seeing is init, right? So this is the actual constructor. There's an underline init, and then two underlines after it. Okay, so this is the constructor. What is a constructor? The constructor is, think of it as a special kind of a function that allows you to set the initial properties of an object. So if I want to make a new circle and I want to tell it initially, okay, you're going to be this big, then I use the constructor to tell it how big my radius is going to be. Okay, the default value for the radius is this new r, and it's going to be equal to 0. So if I make a new circle and I don't provide a specific value for it, then the circle is going to have a radius of 0. It might not make sense, so you might want to change this value to something else. It doesn't have to be 0. You can use whatever value you want. Okay. But if the user decides to provide a value for the radius, then the radius is going to be equal to that new value for the radius, not always 0. Okay. The properties. And by the way, remember that the class circle is a template for an object, and we can create multiple different objects from this template. And just like different circles have different sizes and stuff like that, you can create many different kinds of circles, each of them with different sizes. So that's just keeping it basic. If you have different cars, right, you might have like an object that says, okay, this is what a basic car is. It's got maybe a number of doors, a number of wheels, that kind of things, right? And then from that template, you can create different kinds of instances of an object. Okay, so an instance is pretty much like another term for an object, right? So you're an instance of a human, you're an instance of a human, I'm an instance of a human. We're all objects. Okay, so that's the basic idea. And then each object has properties, right? And what are the properties? The properties are the variables, right? The property of a circle is a radius, right? A table might have a property for weight and number of legs and material and that kind of things, right? A dog might have a property for the dog's name, the dog's age, the dog's weight, right? Dog's breed, those kinds of things. So those are the properties. And then the way we modify these properties in object-oriented programming is using functions. What you have learned about functions, basically function is an action, right? So the way we modify the properties or the variables is using actions or the functions. And in object-oriented programming, we actually call functions methods, right? Don't ask why, it's just they decided we're going to call it a different name, right? It's still a function, right? But basically a method is a function which is inside of a class. And in here I'm just keeping them, I'm keeping the same name because you know them as functions, so I'm going to keep calling it a function, even though it's actually a method, right? So a method is a function which is inside of a class. So at the very least, each object should have actions to change the properties or to see the properties. Right? So in this particular case, this object should have an action to change the radius. So let's say you made a circle with a radius of 0 initially, and then later on say, well, hold on, I want to change the size of this circle. You can do that using the change radius property or function or action or method, right? Same thing. And again, at the very least, you should have a way to change the properties and show the properties. Okay, you could have a lot of other methods in the object or in the class that provide for different other things that you can do with it. In this particular case, maybe I want to have an action to calculate the area and show it to the user, right? And in here I have created an area function which is going to use a print to show you some results. And underneath it I have created a circumference function which will return the circumference of the circle. Okay? Just to give you an example of the kind of things that you could put inside of an object. Okay, so keep in mind that just because of this Python syntax, you have to put the self word inside of the parentheses of these different functions or actions. Right, it's just the way it is. And that's one of the things that I don't really like as far as Python object-oriented programming is concerned. I don't know why they figured out let's just put self in everything. Why don't you just get rid of it and assume it? They didn't. Okay, so that's the syntax. Okay, now underneath it, and then again, I told you that instances are types of circles, or basically the different objects are also known as instances. So how do we create these different circles? So again, remember, this is my template from which I am going to create circles. Okay, and underneath it, and what you should do is you should type up this program. Okay, if you really want to learn, I suggest you type them up. Don't just open up the files and stuff, okay, from the lectures maybe. So anyway, in here I'm creating 3 different circles, right? So circle 1 is equal to the circle without anything inside of the parentheses, okay? So if I do this first line, circle 1 is equal to the circle, then that will call this constructor. So as soon as I do circle1 is equal to circle, just like this, right? This automatically calls my constructor, this init thing up here on top. And since I did not provide a specific value in between the parentheses, then it will assume that the value that I want for the radius is 0, because I said new r is equal to 0 here. Okay? And again, that's just the way I've defined things. Okay? And then underneath it, I'm actually creating different circles. This one has a circle of 10, and this one has a circle, a radius of 10, and the other one is a radius of 1. And as soon as I do those two lines, the 10 and the 1, then the value 10 and 1 will overwrite this value 0. So then I'm going to have one circle that has a radius of 10 and another circle that has a radius of 1. Okay, but again, we're going to call this constructor that we have in here. And again, what is a constructor? It's a special kind of a function that is used one time only when you create an object, right? When you're creating a new instance or a new object, that is when you use the constructor. Okay, so far so good? All right. And then now performing actions on these instances. And again, these are the different instances, and again, these are my constructors, or this is the call to the constructor if you want to call it that. So in here I'm using circle1, and I'm saying dot show radius. Okay. So that is going to call the show radius function, which belongs to the object circle, and it's going to show me the radius for this particular circle, okay, which is 0 initially. Okay, so if I do circle1 show radius here, it will actually show me a radius is 0. Okay, then I'm going to go circle1 change radius, right? And then what change radius will do is it will change the radius to 100. So if you look at it, change radius looks pretty much exactly like the constructor. As far as in here I say self comma new r. Okay, so since I did not provide a value for new r of 0, then that means that I'm going to have to provide some kind of a value inside of the change radius function, right? So notice how I put 100. That value of 100 is going to go, new r is going to become equal to 100, and then my radius for the circle, for this particular circle, is going to be equal to that 100. Okay? And if I go and I do a show radius underneath, then that is going to show you this, the radius now that I changed it to 100. And I can do the same thing for circle 2 show radius. I can do circle 2 dot area, right? As soon as I do that, that will call this function in here. So the way we access the functions that are inside of my object is using the dot. And that is how a lot of the object-oriented programming languages do it. Right? So if you do it in Java, you're going to use a dot. If you're going to use it Python, you're going to do a dot. If you're going to do it C++, actually C++ has 2 different ways to do it because one is not enough for them, right? But they also do a dot. There's an option for you to use a dot in C++ as well, and C. Okay? So, and your program run, the program test run is underneath this. Okay? So, now, one thing to point out is there are different kinds of variables that can be part of these objects. This here is an instance variable, right? So this means that every instance, remember the instances are these circle 1, circle 2, circle 3. So every individual circle will have its own type of a radius, right? If I change the property of circle 1, that is not going to affect the property of circle 2 because they're 2 different circles, right? But there's another kind of a variable. They call, and depending on what language you use, in Java they call them static variables, right? And what is a static variable? It's basically a variable that is shared between all the different objects, right? So maybe you have some kind of a program that requires you to make different objects for the number of employees, right? So you're an employee 1, you're an employee 2, you're an employee 3, but we want to have some kind of a shared variable between all of the employees that keeps track of how many employees there are. So every time I create a new object, and by the way, creating a new object here, what I'm doing here is called instantiation. So I'm instantiating a new object, right? There you go, another term. So as soon as I make a new circle, maybe I want to increase the number of employees, and I want all of the employees to be able to see that same piece of information, and that will be another kind of a variable, which is basically a static variable, which is shared between all the different ones. Okay, so don't confuse an instance variable, which is what this is here, and which is basically a variable for each circle, versus a different kind of a variable which is going to be shared between all the different ones. Okay, so that's that. And there's another example in here in which I have a class person, right? And again, in there I have an init self, which is basically just my constructor. And again, self refers to the person itself. And I'm changing the properties of this particular person to the name is Alex, age is this, weight is this. Okay, and again, I have a way for me to show the object if I wanted to, and I have different ways for me to change the properties of the object. So remember, there's at least you should provide functions to change the properties and functions or function to show the properties at the very least. Okay, plus you might have some other properties in there too. Let's see, why is this different? So you have set name, set age, set weight. Oh, this is to return them. So this one here is this one here shows you all the variables at once. This one here allows you to set each of the individual variables one by one, and this one here retrieves or allows you to look at it, the individual variables of that object. Okay, in here, let's care for the okay. So then underneath it, I have another object called human, right? And again, the object names are completely arbitrary, and actually a lot of times the nomenclature, the way you should write class names is the first letter should be capital. So I'm kind of breaking the rule, but I don't really care. Okay, so but it's not a fixed rule. It's just that in order for you to identify an object easier from all the other things that you made, make it an uppercase, right? Just like I did with the circle up here. All right, if you see the circle here, I followed the rule here, so the class should start with a capital letter, but it's not required. Okay. And what I'm doing here, I'm just giving you slightly different variations of different setups, different classes. So there's another one in here. So the first one here was, by the way, the one thing that's different here is notice how this constructor for the person does not have anything after the self. In the circle, I had a new r, right, a variable which is equal to 0, so that allows me to specify what the value is going to be by default. This constructor does not allow me to set the variables initially to a specific value. So that means that every time I make a new person object or a new instance of the person class, it's always going to be Alex, and the age is always going to be this, and the weight is always going to be this, right? So that's like every time you make one, you can't set the defaults to anything else initially. But later on, once the object is created, then you can use the set name, set age, set weight to modify the properties of the object. Okay? Now, this one here, so this one, again, this first one, this example here is we're always going to make an object with this constructor, so the constructor dictates that we're always going to have these properties for this object. Okay, but then underneath it, I'm making another class called a human, right? Which pretty much has the same properties as the other one, right? So it's just a different name for basically a person, just to illustrate another type of a constructor. So this type of a constructor takes 3 different parameters, but I'm not specifying a default value for each of these. Okay, which means that I will be required to create, when I create a new object of the human type, or a new instance of the human type, I will have to type in some values as I'm creating that object. Okay, and again, we'll wait for me to show this thing. All right, so first of all, let's look at the person. So if I say me person, remember that creates a person called Alex with certain age and so on and so on, and I can't put anything in there. I did not provide for that inside of my constructor. Then underneath it, I'm making a human, but now for the human, because I put after self, I put new name, new age, new weight, 3 different things. I have to provide 3 different arguments in between the parentheses of this human thing. Okay, so I'm saying you, which is an instance or an object, is going to be equal to a new type of human, which is going to be a student with this age and this weight. And then U2 is another kind of an instance or another kind of an object of the human type, which is going to be someone with this age and this weight. Okay, that makes sense? Any questions? Okay, so, and again, in there's ways for you to, show the properties, set the properties of these different ones. Okay, so what I would recommend for you to do is type all these up, right? There's a reason I put them as pictures in there so you don't copy paste them, hopefully. Okay, one thing that I need to point out is, a common mistake is these two are not a single line. These are one underscore and then another underscore, two different underscores. That's just the syntax of Python. Okay, don't ask why. That's the way they wanted it. Okay, so that's that. And the next thing that I want to tell you is class versus instance variables. Okay, so I guess Python calls them class variables. Okay, so that's the one that I was talking about earlier about static variables, about the number of employees and stuff like that. So if we look at this thing here, all right, here it is. We have a class called dog, and again, in order for me to be consistent with the styling of how class names should be written as, I should have D as the uppercase. Okay, so now notice how I have a variable which is not inside of my constructor. It's actually before and outside of all these other ones, of all the other functions, right, or methods. So because it is here in the class, that means that this variable number of dogs is going to be shared by all of the different types of dogs that I'm going to create. Okay, and then in here I have a default constructor which has two parameters. One is a new breed, one is a new age. And if you don't provide a specific string for the breed, then it's going to be a German Shepherd. And if you don't provide a specific number for the age, it's going to be a 1, right? So the default dog that I'm going to create is going to be a German Shepherd with an age of 1, okay? And if you provide something else, then we'll change them according to whatever you provided. So this is one thing that's part of the constructor, right? So it allows you to set the properties based on whatever the user wants. And then the other thing that I'm going to do every time a new dog is created. So remember that the constructor gets called one time when we create a dog, and every time you create a new dog, you're going to use this constructor, and every time that happens, we're going to increase the number of dogs by 1. All right? So that's how we're going to keep track of how many dogs we have. Okay, initially it's a 0, but every time you create a new dog, you go up by 1. Okay, and again, we have ways for me to show the properties of this object. I have ways for me to set the properties of this object, and again, some more methods in there to retrieve them. If I wanted to return them, I can do that too. Okay, and if we go in there, a dog is equal to dog, right? That calls the default constructor, which is this thing here, and since I did not provide anything inside the parentheses, then it's going to be a German Shepherd with an age of 1. Okay, and if I say number of dogs is equal to dog.number of dogs, then I will be able to see that the value for number of dogs is 1 because I created 1 dog. Okay, then I'm going to create another dog. This time it's going to be a boxer with age of 3, right? And if I do another dog show, then it's going to show you that the breed is a boxer and the age is 3. If I do the number of dogs, then you're going to see that now the number of dogs went 2. So even though these are two different objects, just by creating another dog, I actually notice here I'm saying dog1.number dogs. So the property for this dog, which was the first object I created, or any of these objects that I create. So actually notice how I'm calling this here. I'm saying dog.number dogs. I'm not using the object itself. I'm not using the instance itself, right? I'm not saying a dog dot number of dogs, even though I can kind of do that too. Okay, since this is a class variable which belongs to all of the different objects, I can use the name of the object itself, which is dog, to access that particular variable, which is the same for all the different dogs. Okay, so again, these class variables are shared between all the different objects, and changing it for one of them changes it for all of them. Okay, and then in there I make another dog, and I show you the number of dogs again. And then what I'm doing a little bit further down is I'm actually creating a list of dogs. Okay, and this is the kind of stuff that we go in a lot more depth and detail when we start doing data structures. Okay, so in data structures we address these issues where how do we make, a lists of our own type, basically. So you already know what a list is, and Python lists are actually really powerful compared to, a lot of these other lists out there. But like, for example, if we're talking of an array, which is kind of a list the C++ and Java have, an array is very similar to what you see as a list, except it's only of one type. So if I can only have a list of integers, or I can only have a list of strings. If I want to mix them up, I want to have a list of strings and integers, can't do it. Okay, so that's where we address, in order for you to learn how to build these things yourself, then that's what we do in data structures. And that's the reason I'm showing you how to basically add a bunch of objects into an array or into a list of things. Okay, so this collection of objects is actually one of the first topics that I talk about in the data structures class, and that collection of things is known as a bag. Okay, just so you know. All right, and then the data structures class is actually after you take the first C++ class or the first Java class. So here we have, unlike a lot of the schools out there, I teach both of the data structures classes here, but a lot of schools like Hartnell College, for example, only offers data structures in C++. So they have a first semester C++ and then data structures. Okay, if you go to MPC, they do kind of a different thing. They do first semester of Java and then data structures with Java after that. Okay, in here I offer both. So if you want to do Java data structures, I got that. If you want to do C++ data structures, I got that too. If you really want to, understand data structures better, I recommend you take both of them. Okay, because the syntax is slightly different and it allows you to do more things with one language than the other. Anyway, so basically I'm just creating a collection of dogs in there, and I'm calculating the total age, which is basically getting the age of each of these different dogs. Right? Dogs is a list of dogs basically, and I can pull the age of each of these objects and add it up to the total age. Okay, does that make sense? It's a lot of information. It might fly over your head, but I hope you retain some of it. And the point for me to introduce this thing here is to just get you comfortable with objects and object-oriented programming, because if you're serious about computer science or programming, you have to take data structures. Okay, if you plan on doing any kind of a work, you're going to encounter objects. In fact, if you go to a job interview, you're very likely to be asked a question about object-oriented programming and actually data structures questions. Right? In data structures, we have things like trees and queues and stacks and all kinds of different things. And you could be asked those kinds of questions. Okay? So anyway, so now you know what's the difference between a class variable and an instance variable. The next thing that I want to say is, I have some examples in here. My classes, which is probably, that's pretty much, I gave you all the code that I posted in there. Okay, don't copy paste this, just type it up. That's a better way to learn, in my opinion. Okay, if you just copy paste it, or if you just download the file and open it and run it, you didn't learn anything. You learn how to click and click again, right? So type it up. If something goes wrong, even better. Encountering these issues is how you learn how to troubleshoot your programs and understand better. Okay, so those are the two things that I have in there, and that's pretty much all I wanted to tell you. So to go with this, we have a classes assignment, which is you're supposed to create a date class, right? So using all these different examples, I gave you like 6 different examples of classes. You're supposed to create a date class, so the name of the class is going to be date, right? And the class should have 3 properties or instance variables, right? And the properties should have these names: month, day, year. Okay? The class should have 2 functions, one to set the date, and one to show the date. And the set date allows the user to enter a date in this particular format, right? So you can have that kind of an input inside of the set date function if you want. And create an instance. So what you're supposed to do is create an instance of the date class. And again, look at the examples that I provided. I show you how to create instances. And test the object set date and show date method. So what are you going to do? You're going to create an object, an instance of an object, and you're going to have to use the object name dot set date and then object name dot show date to show these different things. Okay? And that's pretty much Let's see what else I wanted to tell you. The other one is the grocery bag. Remember how I told you that one of the first topics in data structures is making a bag, which is a collection of things. Okay, and I'm actually using some of these exact names that I use in my data structures class. So normally you create a class called item, which is the kind of thing that you're going to be storing in the bag. Maybe the item is lettuce and it has a price of something in it, right? And then you have another item called bananas, and it's going to have its own price and stuff like that. And what is the bag? Well, the bag is just a collection of different items. You could have the same item repeat a couple of times. You can have multiple bananas. You should be able to do a couple of things with generally speaking, with a bag, and that is to like see how many things are in the bag, see if particular things in the bag, remove things from the bag, add things to the bag, and that's it. So it's a very general kind of a data structure. Okay, and since I keep saying data structure, you probably don't know what data structure is. Data structure is the computer representation of some kind of a real life thing. Like, let's say you have a stack of plates, right? Well, how do we deal with a stack of plates? Well, you always put the dirty plate on top, right? If you have a whole bunch of stack of plates and you're trying to wash the plates, unless you have a dishwasher, you're going to start with a plate on top, right? Wash that one first, and then you get the next one, and then you get the next one. You're not going to go try to pull the one on the middle or something because it's inconvenient, right? So that real world, I guess, organization of things is the actual, what we call abstract data type, ADT, right? And the data structure is the computer model that we're going to create to solve this kind of a problem. How we're going to arrange things so that things can only be added on one side and can be removed on one side. So the way we do that is, the way to introduce those things is, it's basically, think of it a list, right? But you can only add to one side of the list, and you can only remove from one side of the list, right? So that's one example of a data structure. So and the way you do that is, you're actually going to have the list inside of a class, and then you're only going to provide functions so that you can add and remove on one side of that list. Because normally you can insert in the middle, you can put it in the beginning, you can delete one of them. There's all kinds of different things you can do with a list in Python in particular, right? The list even expands in size and stuff like that, right? But if you want to limit these different things, you basically grab the list, you bury it inside of a class, and that's called an encapsulation. So it's like I'm kind of hiding the details of what's going to happen inside of the class, and I'm restricting the different kinds of operations I can do. So now you know. Okay, those are the data structures, and I spend a whole semester talking about these kind of things in the data structures class. Okay, so anyway, that's what you're going to do. And in here, I guess I have the example with the dogs and making a list of dogs. So this is the example that you need to use to create a bag, which is a collection of items. Okay, does that make sense? Okay, so that's all I have to tell you as far as this week is concerned. Any questions? Okay, so I didn't type up any programs because you have the programs already in here. And again, don't just download them. I mean, if you get stuck on your program and it doesn't work or whatever, then maybe I download the file and look at what went wrong. But if you will learn a lot more if you just type them up and got it going that way. Okay, so that's week 12, and this is the last non-extra credit thing beyond, other than your final exam, which comes in next week. The final exam is, think of it as a final project, right? So I give it to you at week 13, so that you have 13, 14, 15, 16, like 4 extra weeks to finish that thing. And by the way, if you have been doing the homework up to this point, it will be a piece of cake. Okay? So yeah, next week I'm going to talk about the final exam. I'm going to tell you about how to make graphical user interfaces, which are these GUIs, right? And that is where actually a lot of this object-oriented programming comes to use, right? So in graphical user interfaces. So let's say you have some kind of a window, right? Well, you would have an object for a window, right? The window is an object, so every time I make a new window, I don't reinvent the wheel. I just say, okay, pull the object window and make me, use the class window to make me a window, right? Maybe I want to put a button. Well, you can get one object and you can throw another object inside of that object. So you can actually place objects inside of other objects too. Okay, and then also objects can inherit other objects' properties. Okay, so let's say if I have already created a circle object, right? And then later on I wanted to get the properties or all the things that I have already created for the circle, and then I want to make a cylinder object, right? What's the cylinder? Cylinder is a circle with a height, right? So if you add a height to the circle, you made a cylinder. But since I already created the circle, I don't need to reinvent the wheel, right? I'm just going to extend or inherit the properties from the circle into my cylinder object, and I don't have to reinvent the wheel. So that's the kind of stuff that happens when you do graphical user interfaces, right? You already have a button object, or you have a window object, and you just get all those properties and then extend them and inherit them into other objects. Okay, so those are some of the applications. Okay, so very, very important thing, object-oriented programming. Okay, if you actually look at, there's like some interview with Steve Jobs where he talks about, by the way, do you guys know who invented the graphical user interface? Who came up with these like windows and things that we click on with a mouse? It wasn't Steve Jobs. He stole it from someone. Do you know who Apple stole their GUI from? Xerox. Yeah. Yep. And then he actually talks about it. There's like, if you go to Netflix, and look at search Steve Jobs. There's this movie right here, this Steve Jobs Lost Interview. That's the one where he talks about this stuff. He talks about how they invited him to go to Xerox to have a tour, and he calls them ink heads because they didn't know what they had. He makes fun of them. He was like, they didn't know what they had. They snatched defeat from the greatest victory that, he says basically that Xerox could have been the Microsoft of today, but they just didn't know what they were having. But they're the ones who came up with basically, think of the Office, Excel, spreadsheets, Word documents, all that stuff. They had that. The mouse with the two buttons where you can click and move things around. So before Xerox, everything was like a terminal. Everybody had to type up all their stuff in a terminal window like this, and there's a lot of people that they thought this was like the greatest thing ever. Okay, and then he didn't know any better until he actually went to Xerox and he saw that thing. But he says that that's not the thing that impressed him the most. The thing that really blew his mind was the concept of object-oriented programming, which Xerox people also came up with. Right? So then Apple went and stole the GUI from Xerox, and then to make things even better, Microsoft went and stole the GUI from Apple, and then actually Apple went to the ground because of like mismanagement and stuff like that. They actually had to go bankrupt. They're pretty much bankrupt at some point. Microsoft had to fund them like I can't remember how many millions of dollars, but let's say 500 millions of dollars, because there was no competition, right? The United States forced them to pretty much say, hey, look, you need a competitor. Just bring these guys up to speed again, right? So Apple wasn't always what it is. Actually, Steve Jobs was kicked out of Apple, and Apple just went downhill big time. So then he worked on the GUI. So how did he work on the GUI? Well, he pretty much, he had already stolen the GUI, so that was one thing. But the other thing was, they got Unix. So the Apple operating system was such a terrible mess up until the OS X version came up, right? So the modern version of Apple, which is what I'm using right now, is Mac OS X whatever, version 10 point something, right? Up until the OS X came around, Apple's operating system was a mess. You can go back in history and look at what they had, and it was just, they were not innovating. I made fun of Apple for a very long time, right? I wouldn't have switched to Apple unless it actually got better, and it did get better. And why did it get better? Because instead of reinventing the wheel like Microsoft did with their Windows, and it was basically a bunch of spaghetti code, and they kept trying to improve it and then trying to reinvent the wheel and all that stuff. There was an operating system out there way before Microsoft and all these other ones called Unix, right? And what does Steve Jobs do? He used Unix. He basically, what do you think this is? Apple, the OS X is a prettified Unix, right? So he went in there, they kicked him out of Apple, he went and started working on his own project. His own project was basically get Unix and make it pretty, right? So he didn't invent pretty much any of these things. It was just basically borrowing from different people's brilliant ideas. And for the longest time, there were actually rumors that Microsoft is going to do the same thing. Like version 8 is going to be Unix based. No, they didn't.
Unix is very, very difficult to deal with. It is very powerful.
It is very powerful. This is, well, that's what OS X is. OS X is a Unix made prettier. Okay? And it's a very secure, there's actually a, if you go online, there's a Darwin OS. These are the origins of the Apple OS X, the Apple operating system. Okay, because they're look at this thing, opensource.apple.com. So because their operating system was Unix initially, and the copyright issues were such that basically they had to release their software for free initially. So there, if you really want to, I think it's Pure Darwin or something, you can go in there and you can compile the whole operating system from scratch. There's a free version of OS X. It's not the most recent one. It's actually the oldest version of OS X, but it is available for free, and you can download it and you can install it. Okay? Just so you know. Okay? I don't know if you're interested at all, but so yeah, there you go. A little bit of information. I started with the GUIs and ended up all over the place. Okay, so that's all I wanted to tell you as far as objects and all that other stuff. So if you have any questions, let me know. Send me emails. You know the drill.